Okay, so first off we'll just buy a 1 kg bag of table salt from the supermarket. We have the sample bags that we're going to put them into, which will hold the 1 kilogram. Zero the scales, and we note what the weight is for that, and then we re-zero that, and we take, this is a made up 1 kg bag already, but how I actually did that was I put the empty bag back on the scales and gradually filled it again with the salt out of the 1 kg bag that I bought at the supermarket.
To make up
the 1 kilo of salt.
So that's another one you've done earlier?
Yeah. Half a dozen at least of these bags, and just take them with us so that you've got everything ready on the bank for when you get there. You can carry out as many gauges as you've got bags. So ideally you do want, you know, at least half a dozen bags, I would think. The calibration solution that you want, you need 5 grams of salt in a litre solution for the calibration solution that you're going to use on site. So again, you just weigh the empty bag, zero the scales, and make up your 5 grams that way. I make the calibration solution up in the lab.
Yep.
But you do the calibration in the field because you've got to use the field water
okay.
for that.
Yep.
Yeah.
How good is these scales, the ones that they come with?
I'm not sure. They're possibly fine, but I just wanted to get as good a quality as possible, so I use the laboratory scales we've got here in Nelson.
Okay, so if you haven't got any, use these ones.
Yeah.
Yeah.
There's some levels on that inside of that cylinder there. You can see them.
Yep.
I'm just going to set this. They need time to equalise to the ambient water temperature. We've got 4 lights on there, and that red light there should go out at some stage.
That's mean it's connected?
Yep. This one here. Okay, so I've just turned the QiQuac on. This is the startup screen. We want to go into check calibration, so we'll just press start logging, and you can see with it cycling on the right hand side there, channel 0 T, and down to channel 1, it'll just then. Okay, so I've got both probes talking to it. I'll press the button again. We're going to use a 1 kg. I'll push again to get to the next step. Change the no. We want to go into the calibrate, so we're now just hold it to calibrate. Let it go. And it's waiting. It's getting its own readings now. We make sure we jiggle the probes, make sure there's no air trapped in them. Swirl it around a bit, make sure it's complete. This is the background solution, so we shouldn't need any mixing because it's just, there's nothing added into it. We just leave it there like that. Then we push the button again, and here are our first readings. I'm just turning that back 1 toggle at a time. So that's 1 probe, 85.34. The other probe, 85.94. Okay. We have the pipette, and we have our calibration solution. The solution is 5 grams of salt dissolved in 1 litre of water. and we just keep that with us, take that round with us everywhere.
So it's irrespective of the river size
Yeah.
discharge we're trying to,
Yeah, as far as I'm aware, that's correct. Push down on this pipette to this first stop. There's 2 stops on the pipette plunger. Put it in the water, push down fully, then we let it go. It's got the sample in there. Put it over the cylinder where we're doing the measuring, and take the plunger down to the first stop.
so there's always a little bit left in there.
So there's always just that bit left. Then we just make sure this is well mixed. And you can see here, the graph has just picked up the change in conductivity. There's one probe there, you can see it's a solid line. And there's the other probe there, the dotted line. You can see them up top now. Now, we don't have another reading up top displayed because we haven't accepted this value. You can though see the value there, 196.84 on the first line of values there. And you can see the BG, the background, 185.94. If we toggle back one, we've got 196.37 and 185.40. So we'll accept those values by pushing the knob down, and you can see now it's logged that value and it's given us that. So we now then take another sample, or inject the next sample in. Again, mix that up, make sure it's the solution's well mixed. And again, we can see, just looking at that top line down there, what the new value is. 205.84, 206.43. And you can see on the graph there's been another step up. If the values are not staying in reasonably close agreement, give these guys here a shake, because you might have some entrapped air in there. Yeah. There we have both values there again, as in on the graph, and you see it's tracking quite well. So, and they're both pretty stable there, so we'll press this knob again to accept those values. Okay, now you see we've got 3 values there. We've got the background, we've got the first injection, and we've got the second injection. And if you look at those values, you can see they're the values for one of the probes. Turn the knob back one toggle, and that's the value for the other probe. And they're both in pretty good agreement, so we'll continue on. And again, we've got the next step up. 215.88, turn the toggle back 1, 216.31. So that's the readings on the 2 probes. Turn the toggle back again, and again, and there we have both probes showing their trace. And again, you can see it's leveled out pretty well, so we'll accept that next value. Okay, one to go. And again, we can see it's getting a bit crowded on that screen, but on that first line we can see it's 226.45, 0.52. So, and we toggle back to the other solution, 226.56. So again, They're staying in pretty good agreement. So if we press that, that should finish the, there we are.
Okay, so it expects that number, you can't do any more or less.
No, and that value there, decimal 479, is a good result.
So that, yeah, what does that mean, Ralph, that calibration factor there?
It should be pretty standard for most rivers and should consistently be 0.49, decimal 49, plus or minus decimal 02. If it's greater than that, then really you want to look at it, maybe do it again and just check.
And if it's outside that, possibly a probe problem.
Possibly, yeah.
The difference is great between them. Yeah.